Good morning, dear student. In our previous video class, we have learned about a resistivity. So, in this class, we are going to talk about a conductivity. Before going to that conductivity, what do you mean by a conductance? Conductance means it is the reciprocal of a resistance. Resistance means it is the opposition of a flow of charges inside the conductor. Here the conductance means it is a reciprocal of a resistance is called as conductance. Conductance means it is a reciprocal of resistance is called as conductance. Then what is the SI unit of a conductance? The SI unit of conductance is SI unit of resistance is ohm. Therefore, the reciprocal of this conductance is ohm inverse. Ohm inverse is the SI unit of conductance. Ohm inverse or Simon. Simon is the SI unit of a conductance. Ohm inverse or Simon is the SI unit of conductance. Simon is simply written as a capital letter S. So the next one is conductivity. Conductivity. Here also it is said that it is a reciprocal of a resistivity. Reciprocal of resistivity is called as conductivity. Then the SI unit of conductivity is resistivity means ohm meter. Therefore, ohm inverse meter inverse is the SI unit of conductivity or Simon per meter is the SI unit of a conductivity. This is regarding about a conductance and conductivity of a material. Next one is a drift velocity. Velocity. So, what do you mean by drift velocity? We know that velocity, but what do you mean by velocity? Drift velocity means it is the average velocity with which the electron drift in a metallic wire in opposite to the electric field when the potential difference is applied across the conductor is called as drift velocity. For example, let us consider a conductor. A conductor, and it is two ends are connected to a battery to apply a potential difference. In this, the free electrons get drifted in the opposite to the electric field. This is the free electrons. Free electron. These are called as positive ions or atom. This is positively charged, this is negative. So here, this is free electron is drifted like this. When we pass or apply a potential difference by a battery or potential difference. So here when we pass the potential to this conductor, here electric field get generated. This electric field accelerate the electron means a free electron. Then this free electron tend to move or tend to drift in this direction of opposite to the electric field. Here electric field is like this and the electrons are drifted to the electric field in this direction. This is called as a drift velocity. Drift velocity can be defined as it is the average velocity with which the electron get opposite to the electric field when the potential difference is applied across the conductor is called as a drift velocity. Drift velocity is the average velocity with which the electron get drifted or get moved in the opposite direction of electric field inside a conductor when the potential difference is applied. It is called as a drift velocity. Then what is the expression for a drift velocity? So here EVD, here he is the charge of electrons, and E is the electric field in a conductor, and U is the initial velocity, and T, here we are using, instead of T, here we are using tau. Tau represents the relaxation time. I will explain later what is tau. So tau is a relaxation time. And capital V represent the drift velocity. So here we know that it is studied in first PUC. There are three equations of motion. In that, the first equation become V equals to U plus AT. Instead of AT, we are using here tau. So here, this is the equation of motion. So let us consider this equation here. Here we represent the drift velocity or final velocity, drift velocity, and U is the initial velocity, and A is the acceleration of a electron inside a conductor when the electric field is set up here. So tau is the relaxation time. So relaxation time is the average interval of time when the two successive collision of electron inside a conductor is called as relaxation time. So here, in the presence of electric field, electron tend to move because the electron get accelerated by electric field. But in the absence of electric field, here U equals to 0, therefore V equals to A times tau. Here U get cancelled because initial velocity in the absence of electric field is 0. Therefore, we know that the famous formula, the Newton's second law of motion, that is F equals to m into A. Here, simplify A equals to F divided by m. So, in the presence of electric field and charge of electrons, the F can be written as F equals to minus E into E. So, substitute this value to this equation, we get A equals to minus E F divided by m. So, here, now let's substitute this value to this equation number. This is called as equation number 1. This is 2. Substitute this 2 to equation number 1. We get V equals to A into tau. So, what is the value of A? A equals to E minus EE divided by, sorry, this is E divided by M. Minus EE divided 1 into tau. This is V. This is the equation of a drift velocity of a conductor. This is the expression for drift velocity. Here E represents, small e represents the charge of electron, and capital E represents the electric field inside a conductor, and tau represents the relaxation time, and M represents the mass of electron, and Vd represents the drift velocity. This is regarding about a drift velocity inside a conductor. Next one is, what do you mean by relaxation time? I already told that the definition, that is relaxation time. It is the average time interval of a electron two successive collision inside a conductor is called as relaxation time. It is the average time interval between two successive collision of free electron with fixed ion or atom in a metal or conductor. So relaxation time is it is the average time interval between two successive collision of free electron with a fixed ion or atom in a metal. This is called as relaxation time. This is represented by a letter tau. The next one is mobility. Mobility, it is the drift velocity acquired by a free electron per unit electric field. It is the drift velocity acquired by free electrons per unit electric field is called as mobility. Mobility can be represented by like this. This symbol is called as mu. Mu is the symbol for mobility. It symbolically written like this: mu equals to drift velocity divided by electric field. This is called as a mobility. Then the SI unit of mobility is, the SI unit of velocity is meter per second. The SI unit of electric field is volt per meter. Therefore, meter by second into meter by volt. So this is m square per volt second. Meter square per volt second is the SI unit of mobility. SI unit of mobility is meter square divided by V into S. Here V means volt second. This is the SI unit of mobility. And the next one is expression for current in terms of drift velocity. So the expression for current in terms of free electrons. Here also, let us consider a conductor, cylindrical conductor of length L and area of cross section A, and it is connected to a battery to supply a potential difference negative voltage, and here also a positive ions in a metal, and this is a free electron, so moves it with a drift velocity. This is free electrons moving in a drift velocity, and the electric field is opposite to the drift velocity. Here, this is a current. This is current. When we supply a voltage or potential difference to this conductor, the electrons get here electric field is generated. Then this electric field is accelerate the electrons and free electrons are moves with their velocity as drift velocity. It is opposite to the electric field. Therefore, the current inside a conductor, the flow of electric charges inside a conductor is given by I equals to, we already know that this expression I is equal to Q divided by T. This is the expression for a current. It is the rate of flow of charges inside a conductor is called as electric current. Then the total electric charge, the total charge of a conductor is given by is the product of number of electrons, number of free electrons into charge of electrons, into a charge of electron. Therefore, Q is equal to N into E. This is the expression for a total charge. Total charge equal to number of free electrons into charge of electrons. So N into E. Here, the total number of electrons per unit volume is given by. So, therefore, the total number of free electrons per unit volume is given by capital N equals to total number of free electron represented by small letter L, and total number of electron divided by a unit volume V. So therefore here N equals to N into V. Here we represent the volume of a cylindrical, here volume of a conductor. So here the volume of a conductor is replaced by area into length. Here the volume is equal to area into length of a conductor. Therefore N equals to, I will continue here, N equals to small n into A into L. So here volume is replaced by a area of cross section of a conductor and length of a conductor. Therefore, here n equals to, what do you mean by n? So substitute this n value to this equation. We get Q is equal to n into E. Therefore, the next equation become Q is equal to N A E L. So substitute this here. Q to this value to this equation we get Q is equal to N A E L. E remains same. What is the value of N A L? Therefore, this is capital N. This value to this equation. Okay. This is called as equation number. This is 1. This is 2. This is 3. This is 3. This is 4. So Q is equal to N A E L. Okay. Next, here substitute the value of 4, equation number 4 to this equation. We get I is equal to, value of Q is N A E L divided by T. So here N A L into T. Here L divided by T is termed as, it is termed as it is VD. VD means drift velocity. Here the final equation is like this. I is equal to N A E L divided by T. Here the L and T is in the place of L divided by T, we have to substitute VD, because VD means the drift velocity per length of a conductor per unit time. That is a drift velocity. Therefore, I equals to N A small n capital A E into VD. This is the expression for a current in terms of free electrons in a conductor. This is regarding about a current inside a conductor in terms of free electrons. I will stop here. Thank you.